voltaic cell in the honor of Volta and Calvin, right? So in this we'll be studying the working. We'll study the redox couples of these cells. We'll also study the standard electrode potential. We'll also study cell electromotive force for these kind of cells, and we'll see how to represent these kind of cells, right? So we'll study 5 things for this galvanic or voltaic cell. Let's start with the working of galvanic cell. So as I've told, this galvanic cell or voltaic cell is nothing but an electrochemical cell. They are electrochemical cells that converts my chemical energy of a spontaneous reaction or spontaneous redox reaction, to be specific, to electrical energy, right? This is what I have told. This is my spontaneous redox reaction energy will be converted to electrical energy, and that's what happened in this electrochemical cell. And this galvanic cell is nothing but an electrochemical cell. It is the name in the honor of Luigi Galvani and Alexander Volta, right? And they are generally connected by a salt bridge. Daniel cell also, which we just explained, is also a type of galvanic cell. Correct? So the Gibbs free energy of the spontaneous reaction is always negative. And this Gibbs free energy is converted into electrical energy, right? And this electrical energy is used to run the gadgets like laptop, phone, my tube lights, bulbs, correct? And if you see the reaction here, what happened is this copper, if you see, compare zinc and copper about the reactivity, zinc is more reactive, so zinc will have tendency to become Zn2 plus. So zinc becomes Zn2 plus. Since zinc is oxidized, copper is reduced. So we have oxidation couple, we have reduction reaction, right? So these two happen in 2 different portions. The same thing as we have seen for Daniel cell, right? So zinc here, zinc, this is my zinc, and this is my copper. Now zinc, this is zinc, becomes Zn2 plus, and it gives 2 electron here, correct? Zinc becomes Zn2 plus and 2 electrons since reaction. So what happens is oxidation. This is oxidation. So I told an ox, red cat. Oxidation means anode. So this becomes anode. So obviously this becomes cathode, right? So here copper sulfate, it's copper sulfate. This electron transfers from here to here. You get the electron back. This copper sulfate will react with the electron to form copper, and this copper is deposited here. So here reduction takes place, right? And since zinc, a lot of Zn2 plus here is, and a lot of SO4 2 minus is left here. This is left here, these two are left. The difference in charge, the salt bridge helps to neutralize the charge. So if you see, this is the same animation we saw. This is the flow, the green one is the electron flows in this from left to right direction, the current flows in the reverse direction, and the excessive Zn plus 2 in the left container and the excessive SO4 2 minus in the right container get neutralized using salt bridge. That is a typical working of this galvanic cell. So if you observe that the reaction is happening in two different parts, right? This is my oxidation half and this is my reduction half, right? The reaction occurs in 2 different portions. This is my reduction half, oxidation half. So this reduction half is happening at copper electron, and this oxidation half is happening in this case in the zinc electron, right? Zinc becomes Zn2 plus, here Cu2 plus becomes copper. So these 2 portions of cell are called half cells. They are called half cells or redox couple. They call half cells or redox couple. So this copper is called reduction half cell because here reduction is happening. This is called reduction half cell, and this zinc one is called oxidation half cell. Correct. So if you see, each of this half cell has a metallic electrode and an electrolyte. So each half cell has a metallic electrode dipped in electrolyte solution, metallic. Yeah. So each of this half cell will have a metallic electrode and that will be dipped in electrolyte solution. Also note that these two half cells are connected by a metallic wire. This is my metallic wire, right? They are connected by a metallic wire, and through this metallic wire I can attach a bulb or a voltmeter or a switch, right? And these electrolytes of these two half cells are connected through a salt bridge. Correct? These two half cells are connected by a metallic wire, and the electrolytes of these half cells are connected by a salt bridge. And in case where both this both the metallic electrodes are dipped in the same solution, then salt bridge is not required. Salt bridge not required because they are in the same solution, so they can pass the change the ions and it will be neutral anyway, right? And actually using these combination of oxidation and reduction half cell, you can create n number of galvanic cells, because a galvanic cell is a general term, right? The galvanic or voltaic or electrochemical cell, they are same thing, correct? Daniell cell is one of the type of galvanic cell. Similarly, you can have n number of types of galvanic cell, right? Let me explain this. Galvanic or voltaic or electrochemical. They all mean same thing. Now if we talk about the types of this, Daniell cell is one of the type of galvanic cell. Similarly, you can have there are so many types in the market. There are different implementation of the same concept, right, of electrochemical cells. Don't get confused, because this galvanic and voltaic, they are just in the name of galvanic and voltaic, they have given this name to this electrochemical cell, right? In fact, voltaic pile is also one example of this electrochemical cell. Just because this electrochemistry is created by this Volta and Galvani, they are saying that electrochemical cell is also called voltaic or galvanic cell. Just a name. But actually there are different types of electrochemical cell. For example, Daniell cell, voltaic pile. There are so many other types in the market, right? And using two different combinations of redox couples, you can create n number of different types of electrochemical cells. Correct.